Okay, so for our second problem, so let's try to have a look at this one. Okay, we have here triangle OES with a mid segment or a midline of JL, and JL measures 3y minus 9. So we want to know the value of y, given that JL is equal to 3y minus 9 and OS is equal to 47 centimeters. Okay, so the first thing that we can do, we can write the formula for the midline or mid-segment of a triangle. So that's equal to, okay, we can write here as JL is equal to 1/2 of OS. Okay, and then we can write here that JL is equal to 3y minus 9. Okay, and since we know the value of OS is equal to 47 centimeters, we can write that as 1/2 times 47. So that's going to give you 3y is equal to 47 over 2 plus 9. Okay, so therefore the value of y is equal to 47 over 2, okay, plus 9 divided by 3, or that is simply y is equal to 65 over 6, okay, or that's simply 10.83. So the value of y is equal to 10.83 centimeters. Okay, so let's try to check some other problems. Okay, we have here given a right triangle RSC, and we have here three midpoints, point H, point E, and point A. And also we're given here the side measurements of RS and SC, which are 16 and 12 centimeters respectively. And HS is parallel to EA. Okay, so we want to know the perimeter of the right triangle HEA. So you want to know the measurement of the sides of HE, EA, and HA, and we want to add all of those sides, okay, in order to get the perimeter of triangle HEA. So the first thing that we can do is we can find the measurement of HS. Okay, so since HS, okay, so since point H is the midpoint here, therefore we can say that RH is equal to 8 and HS is equal to 8 since we have here 16 as the total side measurement of RS. Therefore EA, since HS is parallel to EA, therefore EA is also 8 centimeters. Okay, we can also do the same thing here at the bottom. So we have here 12 centimeters. Since point A is the midpoint, then therefore we can say that AC is equal to 6 and SA is equal to 6. Okay, and what do you call this? Since it's equal to 6 and HE is parallel to SA, therefore we can say that HE is also equal to 6. Okay, and lastly we just need this hypotenuse. Okay, so again, so 6 plus 6, we're going to get there of 12 centimeters. And now that we know the two side measurements of this right triangle here, HEA, we can now solve for the third side using the Pythagorean theorem. So that will be equal to a squared plus b squared is equal to c squared. Okay, and this will give you 6 squared plus 8 squared is equal to c squared, and therefore we have 36 plus 48, okay, is equal to c squared. Okay, so what's 36 plus 48? Okay, so we have here 36 plus 48 is equal to 84. Okay, so 84 is equal to c squared, and if we square both sides of this the equation, we're going to get that the value of c is equal to 21 times 4. Okay, so we can factor out 4, we can put it here. So we have here 2 square root of 21. In order to get the value of the perimeter, since we know that HA is equal to 2 square root of 21, okay, we can add the three side measurements. So we have here HE plus EA plus SA. I'm sorry, HA. HA, so we have here HA. So it's going to be HE is equal to 8, and HE is equal to 6, EA is equal to 8, and HA is equal to 2 square root of 21. And therefore, our answer is going to be equal to 14 plus 2 square root of 21, or so that's going to be equal to 23.17 centimeters. Okay, so that means this is the perimeter of the right triangle that we have here. Right triangle HEA. Okay, so its perimeter is equal to 23.17 centimeters. Okay, so after proving the midline segment theorem for a triangle, so let's now try to prove the midline theorem. Okay, midline theorem for, or the median of a trapezoid. So a trapezoid's median is also kind of like the median or the midline or the mid segment of a triangle. Okay, so if you notice that the formula is here for the median of a triangle, so it's equal to, okay, so it's equal to 1/2 the third side. Okay, the third side of the what do you call this, of the triangle. Okay, so the third side. But for the median of the trapezoid, okay, so the median of the trapezoid is equal to 1/2, okay, times the sum of the bases of the trapezoid. So that's b sub 1 plus b sub 2. It's almost like the formula of the area of a trapezoid, 1/2 or h, 1/2 times h multiplied by the sum of the bases, b sub 1 plus b sub 2. Okay, so it looks like that, but this is the formula for the median of a trapezoid. So how did we derive, or how did we get this formula? Where did it come from? So let's say we have here, this is the proof for the median, for the formula for the median or the mid segment of a trapezoid. Suppose that we have here trapezoid, okay, trapezoid YRCH, okay, trapezoid YRCH, and its median is IT. And we have here, we need to prove that IT is parallel to RC and also parallel to YH. And also we want to prove, of course, the median of a trapezoid formula. So that's IT is equal to 1/2 plus RC and YH, so the basis. Okay, so we have here on number 1, we can write the given, okay, trapezoid YRCH with the median IT, so that's a given. And number two, we can draw a segment YT. Okay, we can draw a segment YT, extending it until it intersects with the extension of RC. Okay, so we have it here. If you notice here the figure. Okay, so this is our figure here. With the extension of RC at point G. So 2 points, the terminal line. And T is the midpoint of CH, and I is the midpoint of RY. So that's midpoint of a segment forms 2 congruent segments. Okay, so there you go. And since T and I are the midpoints, so we can say the reason for that is a median of a trapezoid joins the midpoint of 2 of its legs. And we created TH, okay, line segment TH is congruent to line segment TC because the midpoint of a segment, forms 2 congruent segments. And also we can say that YH, okay, YH is parallel to RC because in a trapezoid there is 1 pair of parallel sides. We can also notice that angle YHT, okay, angle YHT is congruent to angle TGC, okay, TGC, okay, because, okay, so why are they congruent? Okay, so if 2 parallel lines are cut by a transversal, so you have your YHT and TGC. Okay, so if 2 parallel lines are cut by a transversal, if we extend this, then their alternate interior angles are, okay, congruent. And then we have YTH and CTG. Okay, so let's try to undo that. YTH, okay, YTH and CDG are congruent because they are vertical angles. And using the ASA triangle congruence postulate, we can say that triangle YTH is congruent to triangle CTG. Okay, because we've already proven that the angles here are congruent, and also we've seen that TH is congruent to TC, so that's side. Okay, so that's the side. And also, okay, so we have angles side and we have angles. Okay, this one, okay, so that's angles, what do you call this? Okay, so this should be TCG. Okay, TCG. Okay, TCG is congruent to angle YHG. Okay, YHG, because they are alternate interior angles, and therefore using the ASA triangle congruence postulate, we have two congruent triangles. Okay, so after using CP/CTC, we can say that okay, so after using ASA triangle congruence postulate, we can say that YT, okay, YT is congruent to TG, and CG is congruent to YH because of course, CP/CTC, or corresponding parts of congruent triangles are congruent, since we've already established that the two angles there and its included side are congruent. Okay, for triangles YTH and TCG. Okay, so this should be TCG. Okay, so there you go. And then we have here number 10, point T. Okay, point T is the midpoint of pi g. Okay, so we can say that the midpoint of a segment forms two congruent segments based from our statement here, statement number 9. Okay, so we can also say that IT is a mid-segment of triangle YRG. Okay, so if we can look at here on the figure, so we have here triangle YRG. Okay, so we can use the previous theorem that we proven. So the triangle, the midline of a triangle theorem. So we have here triangle Y. Okay, triangle YRG. Okay, triangle YRG, and its mid segment is IT. Okay, so the mid segment of a triangle joins the midpoints of two sides of a triangle. And we can also see here, okay, that we've already established that we have here a triangle and it has a midpoint here, which is IT. Then we can say that IT and RG are parallel to each other, and also it's also parallel, IT is also parallel to RC. Okay, so we can write that here, IT is also parallel to RC. So the mid segment of a triangle is parallel to the third side of a triangle. Okay, so good. So and then we have here IT is parallel to YH. Okay, so if two lines, if you go back to statement number 5, okay, because YH is parallel to RC, if two lines are parallel to the same line as with statement number 12, then therefore they are parallel to each other. So IT is parallel to YH. So therefore, we can get this equation, IT is equal to 1/2 of RG, and therefore 2 times IT is equal to RG. Using mid-segment of a triangle is equal to 1/2 of its third side. And then we have here RG. Okay, RG is equal to RC plus CG. So that's simply segment addition postulate. And YH, okay, YH is equal to CG. Okay, and that's using the side opposite of congruent angles, okay, are congruent based from statement number 7. Because we have here vertical angles are congruent, therefore they're what do you call this? They're the sides that are opposite them. Okay, so these sides are also congruent, since we've said here that these vertical angles are congruent. Okay, so therefore, using the substitution property of equality, we can say that RG is equal to RC plus YH. Okay, so if we see here, RC is equal RG is equal to RC plus YH. Okay, because since they are congruent, using substitution property of equality. And since we've said that RG is equal to 2IT, also using substitution property of equality. Okay, so let's try to go back there. So that means 2IT is equal to RC plus YH. And therefore, we can get the formula IT is equal to 1/2 multiplied by RC plus YH, okay, using the division property of equality, okay, or the multiplicative inverse when we multiply both sides by 2. And therefore, we got here the formula for the median or mid-segment of a trapezoid.